Chapter 2, Global Infrastructure. Chapter 2 covers AWS Global Infrastructure, regions, availability zones, edge locations, partitions, service availability, latency, data residency, and why placement decisions matter in real architecture. AWS is global, but it is not one giant data center. It is a distributed platform made of geographic regions, isolated availability zones, edge locations, and private global networking. This matters because almost every serious AWS design begins with placement. Where the workload runs affects latency, resilience, compliance, cost, service availability, disaster recovery, and operational complexity. A region is a separate geographic area where AWS operates cloud infrastructure. Examples include regions in Europe, North America, Asia Pacific, South America, the Middle East, and Africa. When you create many AWS resources, you choose the region first. That choice is not cosmetic. It decides where data is stored, which services are available, what latency users may experience, and which regulatory or business constraints apply. Inside each region are availability zones, usually called AZs. An availability zone is one or more physically separate data centers with independent power, cooling, and networking. The point of AZs is fault isolation. If one AZ has a problem, the others in the same region should normally continue operating. This is why production architectures often spread workloads across multiple AZs. Multi-AZ design is one of the most important AWS reliability patterns. The difference between regions and AZs is important. Regions isolate large geographic and regulatory boundaries. AZs isolate local infrastructure failure inside a region. If you design only inside one AZ, you may still have a single point of failure. If you design across multiple regions too early, you may create more complexity than the workload needs. A senior architect starts by understanding the failure target, then chooses the right level of isolation. AWS also has an edge network. Edge locations are used by services such as CloudFront, Route 53, AWS Shield, and other global delivery services to bring content, DNS resolution, and protection closer to users. The edge is not the same as a normal region. You usually do not run your full application there. Instead, the edge improves user experience by reducing latency, caching content, handling global traffic patterns, and absorbing certain kinds of internet-facing load. A less visible but important concept is the AWS partition. A partition is a separate AWS boundary, such as the standard commercial AWS partition, AWS GovCloud, or AWS China. Partitions affect account structure, service endpoints, IAM principles, compliance models, and service availability. Most commercial workloads stay inside the standard AWS partition, but architects working with government, regulated, or China-specific workloads need to understand that partitions are not just regions with different names. Service availability is another practical concern. Not every AWS service exists in every region. Newer services often launch in selected regions first. Some specialized services may never be available everywhere. This means a region strategy should always verify required services before architecture decisions become fixed. A design that depends on a service unavailable in the target region is not a design. It is an assumption waiting to fail. Global infrastructure also affects data residency and compliance. Some workloads must keep data inside a specific country, region, or legal boundary. Others need to serve users globally, but keep sensitive data centralized. AWS gives tools for both models, but the architecture must be deliberate. Replication, backups, logs, analytics exports, and disaster recovery copies can all move data if not controlled. Latency is the more user-visible side of placement. Running a workload closer to users can reduce response time, but moving everything closer is not always simple. Databases, identity systems, integrations, and operational teams may still be centralized. Multi-region designs introduce hard questions around consistency, routing, failover, observability, deployment, and cost. A senior engineer should remember that AWS Global Infrastructure is the physical and logical foundation under every service choice. Regions define geography and legal boundaries. AZs provide local fault isolation. Edge locations improve global delivery and protection. Partitions define separate AWS worlds. Good architecture starts by choosing placement intentionally, not by accepting the default region and hoping the rest works out.